Okay, I'd like to welcome everybody to the September meeting of the Mount Shasta Stargazers. I'm happy to see a lot of new faces in the crowd. So
They
hopefully,
told me they'll keep you there.
oh, is that how we get it? That's your new approach. So anyway, let's go ahead and get started. Okay, so this is what we're going to be talking about tonight. We'll talk about current news and events. And we'll talk about what's up in September. And then explain the nice guy with Stellarium. I must make a correction. Stellarium is not the program,
That's okay.
but it's called planetarium. I misunderstood what Barbara told me. So, but it's a planetarium type program for the PC. So what you learn here should translate to any of the various programs that you find online. And then we'll open it up to member discussions. Okay, first of all, the news, our August star party. The weather was kind of heavy in the afternoon, and I was looking at a program that I use to predict the weather called Astronomy. And what it shows here, the different colors, you have 3 different models that's predicting what the sky is going to look like for a location. And the Mount Shasta, the star party location is right here. So at 2:30 p.m.
Thanks.
in the afternoon, it was looking favorable. All 3 models were forecasting that it was going to be clear
That
in the
looks
area.
favorable to you, Deb.
For Mount Shasta.
Well, which one?
I don't know, the colors, that's a big.
Oh, yeah, no, that's the different models or different colors. The legend is right here. It's the 3 different models, one's yellow, one's kind of blue, one's kind of green. So they're just, this is called an ensemble. So it's the 3 different models, they're displaying them all together. So. And then at 3 o'clock, a little, about half an hour later, it updated, and it was showing this. So this one here, one of the models are showing there'd be cloud cover in our area. So it's kind of a, well, it's just a prediction. It's just kind of a guess, best guess of what it's going to be looking at. You know, we really don't know until we get there. So, and this is what it looked like when I got there. It's actually pretty good. We had some, clouds on the horizon. And this is it's actually 360-degree panoramic. And Lawrence?
Oh.
So it's actually looking pretty good. And we did have 4 new visitors show up for the star party. So there's one couple that came from the Midwest. They had planned this months in advance because they wanted to come out, and their objective was to see the Milky Way. And then we had another young couple that were just visiting in town. And they went to our website and thought we're having a star party. So they contacted Jim, and Jim, said, yeah, it's still on. And they showed up. So that was good.
Really
And there it is around sunset.
beautiful.
So the skies were clear enough. After we got the astronomical twilight, when it got dark enough to see things, the Milky Way slowly became visible, and we were able to see it from horizon to horizon. That was the big thing. I was afraid there would be too many clouds that we couldn't see it from horizon to horizon, but it did reveal itself from horizon to horizon. So the couple that came from the Mideast, they're excited because they met their goal of seeing it. And then the young couple, they're from the Bay Area, where they sound light pollution. They'd never seen it before. And they excited as well. And a bonus, we had if you're familiar with the Starlink satellites, you've probably seen them in the sky, the Starlink trains going overhead. So we actually had not 1, but 2 Starlink satellites. One of them was from a launch previous days, a couple of days before, the star party, so they're clustered close together as they're, being spread out into orbit. And the second one was a little bit older, so they're already fairly well dispersed. What was nice about that satellite tray is that each satellite originated over Mount Shasta. So if you can imagine looking at Mount Shasta, spitting out these satellites,
Yeah,
and it just come overhead. I mean, it was wonderful to see that. So that was a bonus. Yeah, we saw about half a dozen Perseid meteors. So even though it was the late of the Perseid,
what date were you doing this, John?
this is on the
Last Friday?
last Friday. We'll data.
Well, late
Yeah.
August, yes,
Yeah.
okay.
The 22nd, I think, 20th or 22nd, or Friday ago. So, but we saw one particular bright one that lasted 5 or 6 seconds, had a lot of color just kind of falling down the sky. And the young lady who was there commented that she had never seen a meteor before. That was the first time she had seen a meteor. And, coming from the big city, so that was exciting for them. And then I pointed out, I did my best impression of Barbara with my green laser, kind of point out the different constellations. Of course, not
Green
good
lasers are cool.
for entertaining, but I think he got the job done. And so all the guests departed about 10:30 p.m. I decided to stay around and do some observing. And also take some measurements with a sky quality meter to actually get some measurements of how dark it is at that site, to confirm its border scale.
I thought it was pitch black, there was no lights, right?
No, but still you get sky glow, from different cities.
From
Going
the
up
cloud?
into the sky. Yeah. It's hard to see, but, it was a little bit, but the bottom line, it came out to be 21.43, which, we could talk about at a later meeting, how they actually measure the sky.
What would be a
Right.
reading for a typical really dark sky?
I think it's around 21.9. I think when you get to really dark skies, the portal.
So you actually have a higher number for the darker sky. So
Yeah.
the higher the number, okay, so
Right. because they're-
different than a magnitude scale.
Yeah, well, it is a magnitude scale, magnitude.
Yeah.
Almost 22 at zenith for really dark sky, and we're
Wow.
at 21.4.
That's pretty,
And on the portal scale, that's right, in between the portal 2 and portal 3, if you're familiar with that, scale. But I think we're getting a lot of sky glow too from the different clouds. Because typically, we don't get a lot of sky glow from Reading, but because there was cloud cover out there, you can see the reflection of Reading off the cloud. So the cloud soon came over the location, so I wrapped up that point. Now this year, I just took my cell phone out of my pocket when the saw the first Starlink trail to see if I could get something. You look here. You can see it. And you can see one star for reference here. That it's actually moving. So that was pretty impressive.
Are they both moving?
No,
no,
just the Starlink. I was traveling or pointing my camera at the Starlink trail.
Oh,
So, but it's moving relative to the star. So that's why the star was moving as well. Okay, you remember last month when I gave my presentation on the moon, I had mentioned that I'd taken a couple of other photographs at about the same time I was taking on the moon. And I would bring it this month, so. And so here's Saturn.
that's
That was
nice.
taken. And Saturn, right now, the rings are very flat, as seen from the Earth. I think in March of this year, they're actually invisible because it's totally edge on, and now it's fully coming back into view again. It'll take a few years.
You know,
where you could be.
can I add something to that? So
Sure.
when I was teaching astronomy in Los Angeles, right, to high schoolers, I remember one time, I don't know, a couple years in, some kids came skipping into the class, all excited. Miss, I read that Saturn's rings are disappearing, in that they're gonna be gone. They're evaporating, is what the kids had thought. And that's because we've become lazy and we don't actually read. And all the kid did was, of course, read the big headline, right? Saturn's rings are disappearing. And then if you only bothered to read like the next couple sentences was that's because of the orientation of the planet compared to us. And I had to do a whole lecture on stop being so lazy and start reading actually. So that was, there you go. So thank you for
Yeah.
bringing
Thank you,
that.
Barbara.
Yeah.
They say that kids are reading less.
Well, I think all of us are reading less. I'm looking at what I do. I open my New York Times and I don't always want to read. I'll read the blips and I keep going. I too am becoming lazy, Lily, and that's a problem for all of us. I think.
Well, I call it discretionary because there's so much garbage out there now.
That's true. Yeah.
Of course.
And there's Venus, what it looked like.
Nice.
So you can kind of see, you know, the clouds.
Mhm.
of Venus, not a whole lot of details on the clouds.
Mhm.
But one,
Beautiful. Yeah.
What size objective did you use for this? Right?
this is the, well, if you weren't at the last meeting, but when I went to GSSP, I told a story about a telescope following me home or ending up in my
Yeah, I
truck.
was here.
Yeah, okay, well, it was that telescope. It's a 12.5 inch cast ring
Yeah.
telescope.
And what
Well, it's F-16.
Hmm.
The cast ring is F-16.
F-16, but what kind of eyepiece did you use?
No, this is prime focus at F-16.
Oh, okay.
Okay, so for the upcoming events. Okay, this is one of Barbara's events here on 12 October. The Siskiyou Land Trust is doing their autumn dark sky tour. So if you guys wanna join her on for that, it'll be, you know, a very good program. And what I'd like is for members, well, it
No.
depends.
So indeed, so the last time that I did it for the Land Trust, I went to check the normal site that I do it at off of 97, right? And there was a bus parked there, exactly, that looked like it was going to stay there for a while. And I thought, oh my goodness, now what? And so I went to check out up at the old ski bowl. Some friends had wanted me to try going up there. I was always reluctant because it's a lot colder there and because the mountain blocks a fair part of the sky. But Lily, it turned out to be gorgeous. So I ended up doing the last one there. And yeah. And so we're going to do it one more time before they close the gate down at Bunny Flat. So just get ready. It's going to be cold, right? I would bring warm jackets, maybe bring a sleeping bag to climb into, especially for children. Like, is Isaac back there somewhere and stuff? Yeah, there you go. And Isaac, honey, you guys can totally come sit up here. Can you see over everybody from back there? There's plenty of empty chair. Yeah. So if you come join us, you know, I always make sure the kids have warm hats and like climb into a sleeping bag because little kids ooze heat super fast, right? So, but yes, it should be a lot of fun. We will obviously focus on just the autumn skies. Andromeda Galaxy should be beautifully visible, fairly high in the sky. So those of you guys with your awesome toys, please bring your telescopes and so that the audience can go and use it. That would be great. Yeah. If we're already like full up, just let me know and you can totally just
Okay.
come anyway.
Yeah, I was gonna say, you need to sign up ahead of time.
Yeah.
So they're expecting us.
Yeah.
So I recommend, if you're gonna be in town, to do that right away. I'm gonna be out of town myself.
Okay, yeah.
Yeah, so it'll be a great event. Okay, and our dark sky site's gonna be 26th September. You know, usually I give you the different, times, different events. But the moon should be visible for about 2 hours. After sunset. So we'll have an opportunity for people to look at the moon before it gets dark, and then this may be one of the last opportunities where we get to see the Milky Way high in the sky. So I encourage everybody to make that. Okay, and now for the International Observe the Moon Night, every meeting I've been saying it's coming up, the International Observe the Moon Night, let's get ready for this. So,
So what's the
I started-
problem with the park?
well, I'll get it into the next slide, but issues have arisen with getting scheduling the site.
What are the issues?
Well, I'm gonna talk about that. In there. And so as a result, we need to reassess what our involvement or how we're going to work the International Observe the Moon Night this year. And then, of course, we got the planetarium at Medford High School. I still want to schedule for the end of the year. And then the Hat Creek Radio Observatory. So it's kind of,
We've been talking about Hat Creek.
I know. Yeah.
We're gonna make it happen. I'll make it happen. How's that?
And it's during the day.
Yeah. Okay, well, since our event last year, we actually first did it, I think, 3 years ago. We didn't have any problems scheduling the park, people came out and observed. And then we had a good event, yeah. I think it's 3 years ago. And then I think 2 years ago, we didn't have it for some reason, I don't know exactly what the reason was, but yeah, we didn't do that. And then, yeah, something even the one last year, they added a new requirement. That they want to know how many people they're anticipating to show up, and I put in, 50 to 100. And apparently 50 is a trigger for them. So once they saw that 50, then additional requirement came in that I had to get a permit from the city to conduct this in addition to whatever their requirements are. And the permit from the city for a special event, number one, there's, it costs $350 just to sign up, to apply for the permit. And then they wanted a couple of face-to-face meetings and things like that. So I couldn't do that. So I actually reached out to the city manager and explained exactly what we're doing. Even though he said 50 to 100, I told him that it's not a continuous event, like a concert or something, that people come in, spend about 30 minutes looking at the moon and then leave. So we shouldn't have more than 50 at any point. So last year, the city manager granted me a waiver to the city permit. So that allowed us to go on and conduct the event. And now this year, the district added a couple of new insurance requirements. Insurance requirements that I don't think really applies to us, but because I tried to argue that the city doesn't require a special event, but the Parks District still requires.
It's separate.
Yeah, but they consider it a special event. And the reason she gave is because it's publicly advertised. So because we publicly advertise it, we have all these additional requirements that we just weren't prepared to meet. So I sent the information to our insurance carrier, and they responded saying, yeah, that they consider it a special event. So they're willing to give me a quote on the special event coverage. And at that point, I thought, no, we were already, our budget is already blown, just covering this the way it was. So I decided, no, we're gonna find another location.
So what do you have in mind?
Okay. So, number one, we could not hold the event this year. Not have a public viewing, and then just concentrate on an educational display here in the library, set up different poster boards around the library to educate the public about the moon and the International Observe the Moon Night, encourage them on the 4th of October to go outside and look at the moon if they have binoculars, something like that. But I've also been in contact with the Living Memorial Sculpture Garden that's operated by the Kiwanis locally here, and reached out to them, told them what we're going to be doing. The person I talked to said it sounds like that might be feasible, but they're having a board meeting tomorrow night and she's gonna present it to the board. And then we'll find out tomorrow night whether that's an option. But the Living Memorial Sculpture Garden has a nice big parking area where people can drive out, you know, park their cars, and we can just set up the scopes and do our event from there. In addition, they could walk around and look at the sculpture. If you've been to the sculpture garden, yeah, no, it's wonderful in itself, you know, go there, you know, before
How
dark.
dark is the sky? Are there lights in the?
No,
Oh,
no, it'll be dark, the dark part,
yeah, except for the highway.
yeah. But even that's not gonna observe, or not gonna ruin observing the moon. You know, cause it's far enough away, I don't think we even see the light, it's not like the rest area or the observation point that we tried a couple of years ago. So I think that's a viable option for us.
I think there's space to move in off the parking lot.
Oh, there is.
Yeah, yeah.
No, there's plenty of room to park completely off the highway. And then plenty of, there's trees around there, but the moon will be high enough that it won't affect anything that we're doing. Okay, and then, you know, Barbara pointed out that the Mount Shasta Ski Bowl is a good location, so we consider having it up there as well. And then finally, we could maybe do a live broadcast of the moon. You know, using Zoom, so people can see the moon as we're seeing it.
Excuse me, John,
Yes,
has the thought or the Beltran about contact with Seaport?
well, this is not the ski park, this is the old ski bowl.
No, I know, but Ski Park sometimes is open to.
Events, isn't it?
facility.
Yeah,
They have lights
And they-
though, they don't have it,
yeah, they have lights, we,
although
Uh,
maybe where the cross-country skiing area is. I don't know that they have lights.
That's pretty restricted because of trees though. Remember, John,
yeah,
we actually, last year, John and I
we're,
went into the ski, ski bowl. As a facility, and they've got lights around there and there's restrictions on.
Wait, not on the old ski bowl. I was,
No, not on the old, I'm talking about the new.
well, the ski park, that's
Yeah.
what you're talking about,
Yeah.
yeah. I think you would have to get them to turn off their floodlights, probably,
well, and
yeah.
open the gate, cause they keep the gate locked,
Yeah.
so we'd have to make arrangements, and I just didn't, consider that for this year.
What gate?
'Cause I think we've got options.
What gate? There's no gate.
Yeah,
Yeah.
there's a
It's-
gate at Highway 31.
There is?
Do you recall where I think that's where we were at a few years ago? And there was just like hundreds and hundreds of people and hardly anywhere to
No.
park.
No, that was Bunny Flat,
That was Bunny Flat, okay.
yeah, but we're going above Bunny Flat.
So the ski bowl is at the very dead end of Everett Memorial. It's the very last upper parking lot.
So the gates open, in other words.
The gate at Bunny Flat is open through the 1st of November, I think, unless it snows, and in that case, we're screwed, but it's unlikely.
So anyway, that's what we're working with right now. Okay, and you're probably tired of hearing about TCRB, but I just wanna remind us again that, you know, it's likely to happen in the near future, so we'll keep monitoring it and let everybody know when it finally does happen. Okay, and you remember, we talked about last month, the visitor,
Mhm.
interstellar visitor to our solar system, 3I Atlas. And, you know, we kind of talked about it, and I've seen a lot of reports, you know, since then. I think it touches on what Barbara was talking about misinformation. Because, I don't know if you've heard reports about 3I being an alien spacecraft, you know, coming to visit the solar system. And so I found a video, that I think does an excellent job of explaining the phenomenon of why something like that happened. Okay, normally I'd show what's up in June 2025, but we're running, you know, a little bit late, so I think I'm just gonna turn it over to Barbara, and she's gonna tell us what's up.
Okay. Okay, and that's that. There you go. Okay, hold on. Let me just log in. That was great. Wasn't that great?
Yeah.
Yeah. This thing, this sort of makes me remember, have any of you read anything by Michael Shermer? He's a science writer. He would write the skeptic column for the Scientific American. He's written a number of books. He really loves to indeed just sort of debunk a lot of things and so on. And one time I assigned a one pager of his to my science team kids in LA. He basically put forth an interesting thesis. He felt there were two kinds of folks out there, people who desperately needed answers and people who were okay not having answers. And if people absolutely needed to have answers and we don't always have answers, then they need to have a belief system after that to pick up that voided thing. So then there is religion, then there is belief, then there's the God of the gaps, as Neil deGrasse Tyson just said. And those who don't need to have the answer right then, but firmly feel that we will come up with better data and a better understanding, they can do science and they don't need that belief system. And I love that we had a really fruitful debate about that with my students back then. So hi, everybody. I think I have met many of you, but not all of you. My name is Barbara Paulson. I moved to Mount Shasta 7 years ago from Los Angeles, where I had taught a number of different science subjects in high school for 30 years for LA Unified, and started a sort of intense math science magnet program, a school within a school. And my degree is actually in biology from UCLA. I did grad school in art history. Don't ask me why. That's a whole nother thing there. That's a different part of my brain that definitely needed that. But astronomy is really all self-learned by me. So as probably some of you guys also, it's a subject that is just endlessly fascinating. And once I plunged into it and started to coach a science team at my high school, I just could not get enough of it. And then we indeed started a class in astronomy at our school, and then I brought it over here. Let me just get my program set up over here before I lose this too much. So while I'm messing with the technology here, guys, I, being indeed a retired teacher, I prepared some handouts for you guys. Among them, a pre-test, because I always used to go and start my astronomy class with a pre-test. I would not put any of the kids on the spot, nor will I put you on the spot, but I wanted them to indeed know what they know and what they don't know, and also for them to want to know the answers to some of these things, which we would then take a whole semester to go and discover. I will go and share these answers with you, I think, at the end of my presentation there, so you can check it off for yourself. And please get yourself a lovely chocolate as a reward for doing such good work afterwards. So please do that. I also made a map, and I'm having trouble having my computer come up here. So hold on, let me just do this for a sec. The other handouts are a star map that is from oh, there we go. Okay. So hold on. Just make sure we are there. Okay. And I'm just gonna let it click through for a while. Okay. And by the way, yeah, so our map of the planetarium program is right now just clicking through. I maybe will ask the librarian, could we do one more set of lights off, or do they all come off? No, that's on. Off.
Oh, you want off? Oh,
Off. How about? Okay. What do you think? Then you can't see what you have in front of you, but you don't need to see this until later. Okay. So I think that would be great. Thank you so much, Laurie. Appreciate it. Yeah. Anyway, the other things are the sky map that I gave you is, I think, really a wonderful one. It's just available for free on the internet. I always go and print those out or make them available to audiences when I am doing the stargazing evenings. It's a really wonderful overview of what the sky has in it. And I also I've shared with you guys a glossary, which indeed is because John came to my house last week and we were just chatting about what I might be able to share with you guys today. And he banters around and throws about terms that, yes, I do know, but I don't think a lot of folks necessarily know. What is perihelion, right? What is apogee? What is, what the heck is a light year, actually? What the heck are these things? What is a planet? What is a star? What the heck are these? And so having a really good understanding of the basics of some of this terminology really actually gets you a lot deeper into what the heck are we talking about here. So I just felt that I would share that with you. And it's a glossary that I would put together with my kids in front of me. We would stop on some term. Hey, Miss Paulson, what did you just say? And we would define it right then and there. So it's very pedestrian and easy. And I think that's a great place to be. Okay, so, and I indeed want to say some of you guys have a whole lot of knowledge under your belt. I can just feel it. And I know some of you guys to do that. And others just want to know, but don't have a lot. And so please, if I make this a little too simple, nudge me a little or tell me, hey, I know this, but I want to know that. Okay. But my thought was always to bring my whole audience along. I never appreciated teachers who talked way over my head. I would definitely be the kid who asked questions, nor did I want people to waste my time. So here we go. Okay, so I'll put that aside. Oh, thank you so much. And
Yes,
it's a little red someplace over there if I need it. Okay.
Is
sounds
it possible
great.
to share that screen?
Sorry,
Is that possible to share that screen? Are you on the?
She's not logged into
Sure,
it.
okay.
share what screen?
Oh, share it up for the Zoom meeting. Do we have anybody on Zoom?
Oh, I didn't
Just-
realize.
Just you?
Oh,
Okay, but
Okay.
recording.
Yeah.
I see. Okay, yeah, and it's actually, so the program that I'm going to be sharing today, and I indeed decided to do that because it's so easy to, I think, to go and follow what there is, and yet it can allow us to go a little deeper into, for example, the wobble of the Earth's axis of rotation and what that does to the skies, and how might that change the seasons on the Earth, for example. And so I thought I would just start there. It's a program called Planetarium. So John had indeed sent out the blip that I did not go and correct because I thought, well, maybe he knows something more about it than I do. It's not available online. It was something that my dad bought back in the 1990s, burnt me a disc, and I had been using it ever since, even with an external drive, and finally went and put it into my computer. So guys, what I have it set at right now is the skies here, and I can actually, instead of using the little red pointer, but I'm just gonna, can you guys see my little pointer right there, right? Yeah. So over here, I indeed had set the time that we wanted, and this is right now we are at September 3 at just a little bit after 11 o'clock at night because it's been clicking through there. So let me put it to September 2. That is tonight, right? And let's go back to 2000 hours is 8 p.m. essentially, right? And you can see I am having it be clicking and stuff. And the clicking speed is right now set up for every tick, the clock advances by 5 minutes. And so I just wanted you guys to kind of get a sense of what the sky is doing. And we look at it. And do you guys notice any of your friends? Are you able to orient? Where the heck am I?
Well,
We-
it looks like it's,
Go ahead.
West is on the.
So I am, so right now, so Lily, for example, one thing that will tell you something is, do you see that everything is doing this?
Yeah.
On
yeah,
this
that's what I'm
map,
saying.
and that there is a point that is essentially staying put? What will that tell you? We're looking directly at the north, exactly at the North Star, right there, right? So if that is the North Star, that's a good way to go and start orienting right now on this little map. Do you see anything else that looks sort of familiar? It's really hard to do it when it's just dots, isn't it? It's kind of tough. And I thought I would indeed do that to you guys, which is really evil. So let me go back a little bit. So we typically, when we're doing stargazing, what time do we get there? Sometime at sunset, right? So let's go September 2, sunset lately is about 7:30. 7:30 plus 12, 19:30, boom, something like that, apply. So we are at sunset, here we are. Okay, now, how about I help you guys out? How about we do this? The moment we have lines connecting the stars, aren't those like your old friends, guys? Don't you just like feel like, oh, I know what I am looking at. Let me see. I'm so not used to using an external pointer. Maybe I'll just try to do it from here. Do you see this beautiful shape? Does anybody know what this is?
Draco.
This is Draco. There you go. And that little North Star that was sitting there, staying put, what is that attached to?
Ursa Minor.
This is Ursa Minor, or the Little Dipper. Exactly. Exactly. Now, I'm going to kind of back away from the sky so that the stars would not be disappearing on me down here, so that we could kind of see what there was. Oh, there we go. And I'm going to back it up one more time. And maybe I'm going to actually make it stay put for a little bit. So let's go one more time. Apply. Okay, I put it at 18:55, so roughly 7 o'clock at night. Let me make it go a little bit later so we get a little bit more darkness. Okay, boom. We are at about 8 o'clock or close to 8 o'clock. You guys see quite a lot of your friends. One great way to indeed be doing the skies is to, or to orient in the skies is to have a few friends that you look for in the night sky, right? So who are your friends in the night sky? What do you guys look for when you go out there on a dark evening?
Cassiopeia.
You look for Cassiopeia. You love her. Why do you love her?
Easy to find.
Super easy to find. There you go. She's a W in the sky. There you go. Who else has a friend that they like up there?
Antares and Scorpio.
Okay, in Scorpius. And Scorpius, you can see, is not visible right here, right now. Let me look at the southern sky. Aha! And I need to move it up just a little bit for us to be able to see that. There we go. There's good old Scorpius right there. And that's a favorite of yours, Lily. Why is that a favorite of yours?
I don't know, but as long as I've been coming up to the mountain, it was just really bright in the summer sky.
Antares specifically, or the constellation?
Well, the constellation's easy to find, but it was Antares that I
There you
was
go.
focused.
Okay, sounds good. Yeah. Other things. How do others of you orient when you go out there at night? Are you good at reading the sky, or are you bad at it? Do we want a lesson in how to orient a little bit, or do we not want a lesson in there? I don't want to talk down to anybody. Talk, audience.
You've got a wide range here.
We do, don't we? Absolutely,
People
yeah.
who've been doing this for 30 or more years.
Oh, my
and
goodness,
Some people
yes.
probably they're fairly beginners.
There
So
you
it's
go.
hard to,
You may as well go through it.
yeah.
So I may as well go through it a little bit. Okay. So let me do something else. Let me give us a different angle on the sky. Or actually, you know what? Maybe I'm going to leave this for a second. Boom. And I'm going to go over here into my file and into the sky map that I gave you guys. This is a map that I gave you that is out there. Okay. That is available, as I was saying, it's just freeware on the internet. But now I am indeed looking directly overhead, right? You guys all have it. You just don't have the, I was too cheap to do it in color. Therefore, your copy is in gray over there. That's the Milky Way. And here is the ecliptic kind of shown, going and crossing over it at a lovely 60-degree angle approximately. Now, in the summer sky, which is where we are right now, what I say to the audience when we are out there is, look for the brightest objects in the sky. And it turns out that directly overhead in the zenith view is the summer triangle. Here it looks quite small, but it's a really big, lovely thing in the summer sky. And that one is such a great place to start. It's better really than the Big Dipper, which is oftentimes it's our friend, right? Because a lot of people know that one from, I don't know, a million different things. But the Big Dipper sits low in the sky this time of year, whereas these guys are directly overhead, and it's really very wonderful to go and find them. So you guys, when you take this home, if you want to get to know it, it gives it directions on how to use this map around the circle. So I'm not going to go over that right now, but it's very easy. It is the view of the sky overhead. So one thing I remember early on when I started to give this out, kids would always say, wait a minute, Miss Paulson, there's something wrong with this map. It says north up at the top, and then it says west over here, and then down here it is south, and over here it is east. Isn't that backward? Isn't that indeed what, that's not how a compass would be. They have flipped this. Well, it turns out that if you hold the darn thing overhead, the sky overhead is indeed, and where is north here? Roughly that way, isn't it? Something give or take. Essentially, I'm just going to assume that, right? Something like that. So if that is indeed the north, east, south, west, if you hold the map with north pointing at north, sure enough, east will point at east, south will point at south, west will point at west. And it's a very easy map to go and use for folks, but you don't want to be standing there like a goof and your arms are going to hurt. So you simply go and you take your map, right? And whatever sky, so let us say if that is north, let us say that is south. So I find south on the map and I hold it such that I have south at the bottom, and whatever is on the map there is what is in front of me. And then I can spin it. Oh, I'm facing west. Whatever is on the map in the west is right there in front of me. And it works quite beautifully. But they will, if I just lost you right now, you just go ahead and read the instructions and they walk you through that again. And it's super lovely. And it's a nice big overview, whereas my program has, I can't really get all of it there quite as nicely as this. So this time of year, I would indeed recommend that you start with the summer triangle that I was just showing you. Now I'm going to spin this map for us until I have, I think I have, it's over here. I wanted to have north showing over there. And then sure enough, I would say after the summer triangle, you can do what Lily loves to do. And you can see that Antares is sort of low in the southwestern sky. And to me, that's not all that easy to find, Lily. So you can look for your friend, and it is kind of nicely orangish, right? So that's a good thing to orient by. It is indeed has a very strong magnitude. I think it's, I can't remember off the top of my head what they are. But then I typically do go over to the Big Dipper, right, which is part of Ursa Major. And I have been trying, indeed, it's been so low that nowadays, oftentimes, by the time it gets dark enough, you can't really see the rest of Ursa Major. We would see the Big Dipper part, or what's called an asterism, the most recognizable part of a constellation. So there is the Big Dipper. And then the rest of it is supposed to be indeed this bear. So this would be its snout, its body. This is still a part of its body. A long tail. The Greeks gave their bears a tail. Back legs and front legs, right? So that's what the whole constellation of Ursa Major is. But the tail is, and the part of the body is that Big Dipper that we are so familiar with. And once you find the Big Dipper, you connect these two stars, Dubhe and Merak. You just visually connect until, boom, you hit Polaris in Ursa Minor. And then you find the rest of Ursa Minor. And the Little Dipper and Ursa Minor is one and the same in this case. It's the little bear, the son essentially of the big bear mama over there. Something I always love to point out to the audiences at the stargazing evenings. And guys, are you okay? Are you hearing me fine as I am talking? Because I'm kind of talking into my computer, I'm realizing, but I know I'm so friggin' loud that I'm assuming. So please speak up if I am losing you, especially Isaac, you at the back of the room, okay? I would really love to know that I am not losing you. So between Ursa Major and Ursa Minor, Draco the dragon comes up beautifully. Draco's tail is in between those two really recognizable parts of the constellations. And then it comes up, down, and up. In a moment, I'm going to go to my other program. I'm going to see if you guys can find it without the lines, right? Because we don't get lines in the night sky. But you guys can be sure that when I'm getting ready for a stargazing evening, I stare at the star maps like mad so that I can completely visualize the lines between the stars so that when I am out there, I don't need to be looking at something because it's dark anyway, right? And so I am ready to go. I went camping with my family a couple weeks ago, and we had one night of clear skies. And around the campfire, somebody said, "What star is that?" And I said, "Well, of course, that's Vega." And they said, like, "How the hell do you know?" And I thought, just take my word for it. It's like my brother is a gynecologist. He can clearly recognize a fallopian tube when he sees one. I can recognize Vega when I see it.
Hey,
So,
Barbara,
yeah.
just one point.
Yes.
Ursa Major,
Mhm.
the Big Dipper Ursa
Mhm.
Major constellation.
Mhm.
What I've always enjoyed about that is you can see it all year long. And
Yes.
it's interesting to see how high it gets,
Mm-hmm.
and then
How
how
low.
it dips down and almost
Yes.
scrapes the northern horizon.
Absolutely. But it's still
But you
there.
can see it all the time as it moves, and that always, and it's easy to spot. And that's
And you just
always
love that.
been one of my
Yeah.
favorite.
Absolutely. I think that that's a lovely, lovely point to go and make. Absolutely. As we get into the fall, indeed, it's going to be even a little bit lower, and then it starts to rise up here and so on. So spring and early summer, it is beautifully up here. As a matter of fact, what that gentleman just said, all of the what you call circumpolar constellations, the constellations that circle the pole star or the North Star, they are visible all year long, right? Which means Cassiopeia, the person who loved Cassiopeia, she's here, then she's going to be hanging upside down in the wintry sky, and then she's going to come back here, and so on. So Ursa Minor, Ursa Major, Draco the dragon, Cepheus the king, the husband of Cassiopeia. I think Camelopardalis is too faint to really use as a reference and stuff. And then once you get to here, interestingly enough, these guys technically, notice, you should just be skirting the sky too, but they are so low in the sky in winter that you really cannot use those as reference points. So I think that's a great point. Now, before I lose Ursa Major, so not only do we point to Polaris, but we also arc to Arcturus. So we use the handle of the Big Dipper to kind of arc around it until we find this crazy bright star called Arcturus. That is a red giant star, the brightest star in the summer skies. The only star that is brighter from the northern hemisphere is indeed Sirius, which is only visible in winter or later on. It is starting to be now in late night, but there it is. And then if we were earlier in the summer, you would have still, friends of mine had also learned in school, you not only arc to Arcturus, then you spike to Spica. But Spica is now off this particular map and not visible anymore. Couple other things that I want to point out here. And guys, it's so easy to use this. So if you do live in a good place or can drive to a good place where you have a lot of open sky, do it. And then come with it. I will have the updated version for the October stargazing that I will be doing. But here, the Great Square of Pegasus in the eastern sky, and it was rising a little bit lower. Now it's getting nice and high. These four stars that form the body of Pegasus are, quite easily recognizable there. And what Pegasus is, guys, is it's that winged horse, right? This is his head right here. Here are his front legs. And that's all you get. You do not get anything else. There's no back legs. This is not back legs. This is actually the Andromeda Galaxy, kind of weirdly hanging off of him. I've always been disturbed by that. And I don't really see anything else in there. But the Great Square of Pegasus is a very easy, again, asterism, a well-recognized part in the sky to go and see. And guys, notice that Saturn, the planet, is now sitting just coming out of Aquarius and into Pisces. So right here in this part of the sky. Okay, so now I'm going to leave that map. So you guys have that map to take home and study up, boys and girls. And I'm gonna get rid of this and I'm gonna come back to my planetarium. Boom. And I'm going to enlarge this. And now, so what did we talk about? So, and this is a little bit harder for me to manipulate up and down, but if I do, so you guys are seeing everything, right? So now I'm going to get rid of the lines. Boom. Oh boy. Let's give it a little bit more darkness. Let's make it a little bit later. How about this is, I'm just going to take it to even hours. Boom, 9 o'clock at night. That's pretty darn good. Okay, 9 o'clock at night. It's as good as we're going to see stuff. How about I'm going to get rid of the cool objects that are not stars. So those were galaxies and nebulae that you could or might not see with a telescope. And let's make it be a little bit bigger. Can we see, as we stare at this, can we see some of it, guys? Do you see this? Can you point him out? Yeah. And what if I arc to Arcturus? Oh, there he is. And that's in the constellation Boetis right there. And back to, again, the Big Dipper. And if I follow it this way, boom, what am I hitting? I am hitting Polaris. Now, can you follow it over here to the Little Dipper? I think you kind of can. It's pretty darn small. If I make it bigger, I lose the bottom of the sky here a little. Maybe not too much. Not too bad. Here's the Little Dipper. And then between the Big Dipper and the Little Dipper is the tail of, what did I say? Draco the dragon. It comes down like this. And then, oh, here is his head. Right there. Let me put the lines back. Magical lines, help me out. There we go. Here is his head, and there we go. And one reason I'm spending a fair amount of time on Draco is he's going to become really important for us in a moment. And I'm going to be changing things around here a little. I thought I would spend a bit of time letting this program kind of do its thing, but I think we spent a lot of time on housekeeping and so on, John. I'm going to shorten what I had prepared a little bit. So in any case, please notice again that sure enough, everything is circling. How would you typify it to someone who is not able to see this? What are the constellations doing vis-a-vis the North Star? They are moving
East.
Okay, how about, yes, east to west, fine. Or if you're looking straight north, they're doing what kind of a motion? How about counterclockwise, not just circle, but counterclockwise, absolutely. So guys, we're staring at this. Do you want to see what's happening at the other end of the earth? I have this set up actually by default to Medford right now. So that's the sky directly over Medford. I'm going to go to the South Pole. Want to see what's happening there? And tell me, what do you think is going to be happening there?
Clockwise.
Okay, let's go there and see. Ready, ready, ready? See, now I'm seeing Antarctica and... Ooh.
Mm-hmm.
Okay, it's going clockwise. Notice something else. Is there some kind of a thing that they are circling around? I'm going to back up a little so that we can see. Okay. Notice, guys, everything is sort of going and spinning around just like that before. I had it set, so we are at 41.5 degrees north of the equator, but the South Pole is 90 degrees south of the equator. And is there a star there that it is all going around? No,
No,
it is. There is no South Star the way there is a North Star, right? So that is something. Do we know any of these constellations? If we are at the South Pole, have some of you guys, those of you who know your stuff, come on. Some of these should be your friends. Yeah. Let me make it a little bit bigger. I think I can still afford to do that. Okay. How about this is somebody upside down who is really well known. We see him in the winter beautifully. Really bright star, brighter than Arcturus.
Serious?
Yeah, in what constellation?
Oh, Canis, Major.
Canis Major, very good. So that's the big dog, or Orion's dog, if you will, right? Something like that. So there you go. So those were some. There's Lepus, or the rabbits. We can see him sometimes, indeed. How about over here? This is actually Hydra and Corvus and Crater. We see them as well. Oh, look at Lily. Here's your friend, but it's looking funky. So when you are at the South Pole, you do see some of our friends, right? So, consider our Earth is tipped at a 23.5 degree angle, right? And so sometimes we're seeing some of the southern celestial hemisphere. Sometimes they're seeing some of the northern celestial hemisphere because there's a funky little toggle through winter and summer, where sometimes they see some of our stuff, we see some of theirs. But there are some constellations we never see. For example, the mariners, I understand, always used to look for that Southern Cross. You will not see that from here, no matter how hard you try. We have a Northern Cross. That's the asterism inside Cygnus the Swan in the Summer Triangle. So let's go see what it looks like at the North Pole. So let's go the other way. It's so fun to do this. I feel very powerful. So now I've gone there. Notice I'm in the middle of nowhere. So now the skies are spinning correctly again. I'm going to back up a little bit so that we can see where it's circling around. Can you guys sort of see? And actually, I can make it bigger. That's all. And I'm going to give us more darkness. Let's give us some darkness. And I've gone now to the fourth. We're back at the second. Let's go. And since I'm having to shorten it, my presentation here, I am gonna, oh, that's right. I'm not gonna give us much darkness. I forgot what time of year we are. We are, at the North Pole, guys, you don't get a whole lot of darkness. Yeah, you will start to pretty soon, but not yet. So first of all, what is directly overhead at the North Pole? The North Star. There it is. So the North Pole, indeed, is 90 degrees latitude. That means 90 degrees above the equator. And so sure enough, that's why the pole star, or the North Star, is 90 degrees dead overhead at the zenith view. We are at 41.5 degrees north of the equator. So guess where our pole star is? It's at 41.5 degrees north of the horizon for us. So ladies and gentlemen, think about it. 0 degrees horizon, 90 degrees dead overhead, zenith point, right? When you are at the North Pole, the pole star is directly overhead. For some of you guys, you totally know this. And for other people, this is a light bulb moment. So please, you're just going to kind of carry on with me, right? We are 41.5 degrees above the equator. That's our latitude. So our North Star is that high, right? You can do the angles. So that's kind of cool to do angles. If something is 60 degrees of sky, 90, 0, oh, this is about a 60 degree. So I'm looking pretty darn high in the sky. So even if you have trees around you at your house, you can oftentimes see the top 30 degrees of sky, but the rest gets eaten up, right? So there we have some of this. So first of all, so here we have the North Pole. Now, why is it being so light up there? What's going on? Well, we're still sort of at the tail end of summer, right? As you get further into winter, how about let's give us some winter? Let's see what it looks like. Where should we go? How about, should we go to I'm going to go not quite to the shortest day of the year, but close. December 3. Fly. Ooh, and it's supposed to be 9 o'clock in the morning. This is 9 o'clock in the morning. Why? Isn't that weird? Right? So again, at the North Pole, you get just about 24 hours of darkness at around December 21. And so on. So we're getting close to that. So the stars are still doing their lovely counterclockwise motion and stuff. It would be a heck of a place to go do stargazing, wouldn't it, John? That would be amazing. So now there was one more thing I had wanted to do. I had other things planned, but let me do this. So we've been clicking every 5 minutes, and I'm going to come back to us. So I'm going to go away from the North Pole. I'm going to come back to, I wanted to go to Zimbabwe and other places, but we're not going to do that. I'm going to go back to Oregon. Medford, that's close enough to us. Notice 42 degrees or so. We're a little slightly south of that. I'm going to do this, and then I'm going to come back to here. Oops. November 2. Let's go, let's say, that's close enough. Fly, sky. Okay, now we are going to do this. As I was saying, the North Star, indeed, right now stays put because the Earth's axis of rotation points at it. But the Earth's axis wobbles. Those of you guys who are totally steeped in this, what is that wobble of the Earth's axis called?
Precession and equinox?
Precession. Just precession. The fact that it's precession of the equinoxes means indeed that the equinox, the vernal or spring equinox, moves through the zodiac as indeed the Earth wobbles on its axis. So notice that Polaris is not exactly staying put. It's making an itty bitty little circle, but it's pretty damn good. I am going to make the clicking change. I am going to, instead of every 5 minutes be a click, I am going to make the click be, every click is make it 100 years. Okay, so let's see. Every tick, the clock advances by 100 years. So here we go. So now, okay, now hold on. Why did it just do that? It should not be doing that. I did something funky. It should not be turning the wrong way. It should be turning the right way. Why is it? What did I just do? And I was practicing this at home to make sure I don't screw up. What did I do? Normal 100. Did I, the 100 years, every tick clock advances by 100 years. This is correct. What did I do?
Going backwards.
Should not be going backwards. Should not be doing that. It will do it the right way, but for some reason.
Anyway, we're gonna have a new pole star someday.
We will indeed. And not only that, but I wanted to show you guys, we had a different pole star 5,000 years ago. It was Thuban in Draco. 1,000 years from now, it's going to be Erai in Cepheus. And then it's going to be pretty close to this star, whose name I cannot remember. And then it's going to come pretty darn close to Vega and stuff and do this. But I have no idea what I just did. Oh my gosh. This did not happen at home. Don't you love it when something weird happens with your program?
Aliens.
Aliens. The guys here. I don't believe in aliens. So, oh shoot. Okay, that's ridiculous. Okay, wait a minute. I'm going to shut this program down. Let's see, right? Hit it with the hammer and then come back. Isn't that how it works, guys? I think normally, okay, let's see if we can do this one more time. Because it's really totally worth it. That was the last thing I was going to do. So let's just see if I can set up from scratch. Come on. Yes. See if it'll fix it. Planetarium. Boom. Thank you very much. And now, okay, return 5. We're good. And the clicking thing, oh, it still is there. And then I don't see anything weird that I did with it, but it is completely doing something screwy for me, guys. So I don't want to do screwy stuff. That makes no sense. Oh boy. Because clearly planets don't rise in the west. Okay, what does the teacher do when technology will not cooperate? Look at this, everything is rising in the west, so we're going backwards, and I don't want to go backwards. So hold on, one more time. Advance.
I'm sure time is advancing forward.
Yeah, but I didn't change anything plus.
I
I
mean,
need to, I wanted it, hold on, let's just see. Now it's doing, okay, so we're fine now. Okay, now hold on, I need to come here. So we're at some weird time right now. I need to instead do, okay, I think I might have indeed, I was nervous. And so I probably clicked on some little plus sign that I never even saw. So here we go. Okay, let's see if we've got it. Okay, and cross your fingers and okay, every click. Now they're correctly setting, and this is possible. So now, guys, notice what is happening with Polaris. Indeed, it has moved away, and I'm going to keep the arrow where the axis of rotation is pointing. Oh, no, now I am going backwards. No, it was correct, guys. No, hold on. I know. I'm being adult. I'm sorry, everybody. It was correct before. Because you see, now I am going backwards. So fine, I'm gonna let it go backwards. Going backwards to when the Egyptians were building their pyramids. And look at, boom, let me stop it right there. Where am I in terms of the clock? I am at the year I am 3,276 years ago, and the star that was the North Star was indeed Thuban and stuff. So no, I had it right. And I think my mind just went wrong. You guys, what all of you guys said when it's going backwards, it's that we were expecting everything to do that, but we're talking about the precession of the Earth's axis, not day-to-day movement of the stars going counterclockwise. I made a major boo-boo. I'm going to go back here, sorry, and do this again. So I'm just going to let it click the correct way for us. So instead of putting a minus sign, I'll leave the plus sign. There we go. Apologies. You thought I was going to do such a good job. There you go.
they did a great job.
It drives me crazy. You know, when you're making a public mistake, that's a real bummer. So there you go. I'm gonna go
Isn't
20.
the pyramids older than 3,000 years though?
The pyramids were built roughly, give or take 2000 BC. A little bit.
Right.
Absolutely, yeah. And so we are, they are older than 3,000 years, Lily, but it's close enough. So when I was looking it up, the Egyptians did indeed use, let's see if I'm clicking correctly right now. Yes. No, I'm still there. Come on. I'm going to go to the plus, apply, and now here we go. Okay. Yes. Okay. So our axis of rotation, ladies and gentlemen, does something different than the normal day-to-day movement. What it does is where I am pointing is you can see in roughly 1,000 years from now, and I'm going to stop it right there for a second. We are at the year, well, 4,300, but it has clicked away. So in another couple of thousand years, that different stars are going to come right over our axis rotation. And I'm not able to catch it fast enough. I apologize. And in whatever year, I see it down here at the bottom, in the year 7,000 something, this will be the closest star to the axis of rotation. And then pretty soon it's going to be, and we're just going, and I'm looking in the right hand bottom corner is actually also giving me the years. So there we go. Yeah. We are going to be not super close, but close enough to Vega in the constellation Lyra. You see it coming up. This is who I am waiting for right there. And ultimately, and I know everybody, I think I'm starting to feel everybody wants to go home. So I'm going to pause this for a second. What the axis of rotation does is it is doing this sort of a motion. It's going, it was there about 5,000 years ago. It's coming, it's at us now. It's going to come over here. And then it's going to come over to here. And then it's going to come this way and roughly here and there. And then that's really the last one that it's going to come very close. And it'll come back to Thuban. And then it will come back to Polaris. And it takes 26,000 years to complete one wobble or one precession. So one total wobble of the axis as it spins through these things. I think unfortunately, I am thinking we need to put an end to it. Well, how long do you guys normally go?
7:15.
Yes, and I think we're already over that. It's close to 7:30. So, ladies and gents, I think I also was not expecting to be here quite this late. I had wanted to discuss a little bit about what this precession might do to seasonality. It both doesn't have much effect, and yet it has some effect on things. There is something called the Milankovitch cycle, which is a whole nother thing of our axis of rotation changing its obliqueness from where we are now, 23.5 degrees. It can be as little as 22 degrees, and we're heading in that direction. So we will be a little bit more upright, and then we will be a little bit less upright again. And it does that in a period of about 100,000 years. So there is a lot that is going on with the skies, with, and so on. And you can really tell what the axis is doing from looking at the night skies, because those are the points in space that we can go and take a look at. But I can feel that I have indeed driven the audience crazy.
Barbara, I believe.
Yes.
That a lot of scientists believe
Uh-huh.
that this precession and other
Mhm.
factors in the way the Earth and the solar system interact can also be causing climate change, or at least one of the causes of climate change. And it's probably been going on for
Yes, but so,
billions of years.
I have had long discussions with my dad, who was really a very good amateur astronomer, who would always bring up this stuff with the Milankovitch cycles and stuff. And I've read plenty of stuff on it. I personally don't support that. I think that the amount of CO2 that we have been dumping into the air for the last 200 years is going to clearly outweigh whatever the other stuff that is adding to it or change. Obviously you cannot discount it completely, but it is not fully responsible for what we are seeing. Exactly. And a lot of people who don't want to think that we really need to clean up our act and stuff, they point at these other things and say, well, we're not to blame, so we may as well just party hardy, and keep going. Yeah.
Do the Milankovitch cycles, do they have anything to do with the ice ages?
That's a really good question.
That's my point. I think
Yeah.
it's
Thank you.
debatable, but I think there's a lot of evidence over billions of years of Earth's changes.
And long before humans had anything to do with it.
Right.
Totally.
Yeah, exactly.
I agree with you.
Yeah,
Yeah.
no, I think there's a good YouTube video talking about with.
Yeah.
None of it at the rate that we are changing.
Right.
Exactly. And the thing is, back to your ice age thing. So the last ice age ended about 11,000 years ago. The Milankovitch cycle is about 100,000 years. And so I think therein lies much of the answer to you right there. I just think that it really couldn't. But the interaction between any number of things, so again, the axial tilt together with all kinds of stuff, a little bit, right? I even at one point, we really spent some time diving deep with my students into this thing of, the Earth's magnetic field flips poles, right? A lot of you guys know that about every 15,000 years? Is that?
It varies.
It varies. So it's not exact.
It's not
But,
consistent.
what does that do to things too, right? There is so much out there. And the one thing though that I have learned, like tonight when I was, and those of you guys who wanted to indeed see, and this is just a very rudimentary little pretest, but I thought you would have some fun with it if you were doing that. One of my friends, she's been indeed lately sort of reading all kinds of stuff. And again, now like she brought up that three-eye atlas thing, and I'm saying, come on, and I'm trying to gently explain. And then today she brought something else, which had to do with, what the heck was that? Oh, that Voyager 1 supposedly is sending information from aliens to us from beyond the heliopause and so on. And there's YouTube videos on this. And again, I'm just, and therefore it must be true, right? Because it's on YouTube. And it's so hard. It's obvious if somebody picked up something, like there was a glitch, there was a bad chip on the Voyager and they had to change it out and stuff. And I went dove deep so that with my friend, so I could show her where probably this misinformation first got its grain of truth. But then they go into some nonsense areas. They just make shit, it's sort of what we call it in our family.
Barbara,
Yeah.
back to the stellarium.
Yeah.
I might point out that.
So this is not Stellarium, by the way.
Oh, I thought it was.
No.
Oh.
So this is called Planetarium.
Oh, I'm
It's
sorry.
a different program. Yeah, that's
I
okay.
point out,
Huh?
Stellarium is an app that you can load on your smartphone. I have it.
I have
And you
an
can
app as
point
well.
your phone up at the night sky, and it will identify which constellation you're looking at and
Honey,
everything else.
I think we all have it. I use Skyview Lite. I love that one. It's the light version is free. I'm too much of a cheapskate. It works beautifully and so on. Yeah. No, but this is not it. This is actually, they have a whole lot of data in there, and there's a lot in this program that, it allowed me to teach a significant portion of my class with that. Yeah. So guys, if any of you, and if some of you have any differences with the answers that I give here, and obviously some of them where I just put ... obviously that's, answers vary, right? But if any of this is of particular interest to you, I would be happy to come another time and do a sort of a deep dive lecture on anything in particular that we would like to. And I am, I have read a lot, but I can clearly see that a lot of you guys bring a lot to this. And so it would be nice to have a joint effort is what I would like. I think that's a great way to go and address the night skies.
Yeah.
Okay. Wonderful. Okay. And with that, I think I am done for tonight. Thank you. I really appreciate it.
Wonderful presentation. I think, now that you told me that you have a planetarium, I don't think I've heard of planetarium. I don't think it's available anymore,
It's
but
not.
I'm surprised it still runs on Windows.
Isn't that amazing? I know. I was a little worried when I updated to the latest window version,
Yeah.
and so far so good.
Yeah.
So there we go. Yeah. Yeah.
You're thinking about you guys.
I don't know.
Yeah.
Finish the meeting then, kids.
Yeah, no, I think we're. Let me see how Lori's doing here. You okay?
Yeah.
Okay.
So I think we're gonna take everything apart then. Yeah, and I apologize for that one glitch. That was my brain glitch,
No.
not the.
No. That's no worries.
Isn't that funny? How all of a sudden something
I thought-
happens? Yeah.
It thought occurred to me that, we're not looking at that diurnal motion.
Of course not.
We're looking at the.
And that's, had I not been rushing, I would not have probably caught myself in that. Yeah. Good. Hey, ladies and gents, yeah. And by the way, if some of them, if they're driving you crazy, that would be the great point of departure. What I would normally do is I would go over that stuff, and right away the kids would go, no, how can that be? Wait a second, isn't it like red hot? For example, with stars, right? A lot of kids assumed that something that is red is hot, and we know that in astronomy, it's actually quite the opposite, right? Or, other things, or like kids would arrive in class and vast majority of kids could not name all the planets, and they certainly did not have them in order. And so that this is just how it is. And they're supposed to learn the solar system in third grade. That's the third grade California science standards, and it doesn't stick. So I feel like we should be walking around and having some basic information under our belt. And so there's no shame in not knowing, but there is shame in not wanting to, right? I think it's sort of how it goes. So, yeah.
All right.
Thank you.
Well, thank you, everybody,
Thank you, sir.
for showing up. I hope everybody, you learned something tonight. You know, Barbara did a great job
Thank you.
talking about,
John, you're doing a great job.
You're good.
oh,
Thank you.
well, thanks, I'm trying, but, yeah.
Um,
But thanks
Ladies and
again.
gentlemen, October 12th, indeed, it's gonna be up at the old ski bowl, you know, unless there's like a blizzard or something like that. Yeah, obviously, we move it, if the, weather will not allow, and then I just have as a standby the next couple of evenings, and I would love to see some of you guys there, because then the questions are richer and the discussion is richer when it's people who really know something about the sky. Like you, Doug, that time you were pointing things out, right, at the last one, so it was really. Thank you.
All right.
Thank you.
And if you have any thoughts on, you know, the coming up, the International Observe the Moon Night, go ahead and email them to me.
That's me be here, right? Or no,
Well, we don't know exactly where it's gonna be.
John,
Yeah.
we mentioned, that if it's publicly announced that that is a showstopper. Is our website, if we announce it on our website, is that considered being publicly announced?
Yeah,
I think the important thing is from now on, maximum number of people that we expect is 25.
yeah, but if we do it publicly,
Yeah.
yeah, and they require us to have $4 million insurance.
We'll get it.
Yeah, I think that, yeah,
You know,
it's a pretty
by the
conceived
way-
idea of what we do. Well,
John, the thing with the insurance, find out from the Siskiyou Land Trust what they do, because we need, as far as I know, we don't get any permission, nothing, and I don't know if they carry any kind of liability insurance, but
yeah,
you know, we typically have up to
I'm sure
50
they-
people.
yeah, I'm sure they do, but